Good morning or good afternoon, everyone, depending on where you're joining us from, and welcome to today's webinar. My name is Freddie Lawton from Business Review, and I'll be your host. It's our pleasure to have a vote core with us today, who will be discussing Every Drop Matters. Today's guest speaker is Francis BORDELEAU, who is a FORTESAND water expert. I'd like to welcome you to our webinar platform On24. You'll notice that this webinar is browser-based, so if you disconnect for any reason, please just click on the link that you receive via email to rejoin the session. In order to ask questions, you can send them in via the questions widget, so just type them into the box at the top left-hand corner of your screen and click submit. We allocate around 10 to 15 minutes at the end of the session to address any questions or thoughts that you may have. If you click on the survey widget, there are a few questions in there for you to answer in order to provide feedback, and you can do this during or immediately after the webinar. Please use the yellow help widget if you require any assistance, and you can move, resize, and maximize any of the windows in front of you to get a better view of the slides. But now please allow me to welcome Francis.
Thank you, Freddie. Good morning, everyone. I'm pleased you could all join us today, and a special welcome to the early birds and to those who are up late to attend the webinar. So I joined Evoqua about a year and a half ago in 2015, but I have 25 years of experience in the business. I worked for several major equipment suppliers in the past, consulting engineers, and I'm currently responsible for FORTESAND sales in process water applications. My colleague Keith is responsible for heat transfer applications. Let's look at today's agenda. The presentation will be about 30 minutes, and there will be a question period at the end. And the topics we will cover today, well, first off, we'll look at how to assess and acknowledge your water filtration requirements. I will submit to you a number of questions that you should ask yourself and ask your water treatment expert in order to assess your needs. Then we'll look at the side effects of not effectively and efficiently filtering small particles. We'll try to understand the differences between MICROSAND and traditional media filtration. And we'll look at CROSSFLOW MICROSAND technology and how it can help you attain your water treatment objectives. And then we'll look at 3 case studies. But first, we'd like to ask a few questions to our audience. Freddie?
Yeah, thank you very much, Francis. So it's now time for the first poll that will be running in today's session. So audience members, if you could please select the answer that is relevant to you and then click submit. So the question is, what aspects of my topic do you want me to focus on today? 3 possible answers are how to assess and knowledge your water filtration requirements, the side effects of not effectively and efficiently filtering small particles, or understanding MICROSAND, media filtration, and CROSSFLOW technology. So audience members, if you could please select your answer now. And Francis, perhaps you could just briefly comment on the question, just to give our audience a bit more time to vote.
Absolutely. First of all, we will go through the assessment of your water filtration needs. We will look at the effects of filtering or not filtering small particles, and we will also discuss the CROSSFLOW technology. But feel free to tell me where you want me to focus on today, and I will try to address and spend more time on that aspect.
Excellent. Thank you, Francis. Well, let's have a look at the results. So interesting split there. Leading answer with 46.9% is the last one. So that's understanding MICROSAND, media filtration, and CROSSFLOW technology. What do you think, Francis? Is this more or less what you were expecting?
Yes, of course, because it's a relatively new technology for many of our people in the audience, and I understand they want to learn more about it. But let's first start with assessing or asking questions about the assessment of water filtration requirements, if you'd like. Well, you know as well as I do that in everything we do, water is a key component. It's a key component of our processes. It's a key component of our product, either as an ingredient or as a medium for chemical reactions. It's also sometimes a carrier fluid for heat transfer. Sometimes it's a byproduct that is discharged to the environment, or it's a resource that can be reused, right? So as a manufacturer of products or as a service provider, you are a manager of resources, and water is one of those very important resources. As you manage this resource, as you manage water, and also as you choose your partners in this task in your industry, I invite you to think as a project manager and to try to optimize the productivity that you put out, but also try to optimize cost, time, and quality and risks. So what does that mean? It means as you manage water, you will want to increase your scope or the quantity of products you put out, reduce your costs, reduce the downtime, and improve your lead times, increase the quality of your product, and of course increase safety or reduce the risks associated with water. What are the drivers that you're facing? Sometimes the drivers are external. They are your client's expectations for product quality, for example, but they can also be your own drivers. They can be regulations. They can be discharge regulations. They can be regulations put in by an organism such as ASHRAE, for example. They can be equipment limitations. They could be limitations that heat exchangers have for particle sizes. They can be limitations from RO manufacturers. So let's look at the applications that you might be facing. An application is defined as a process transforming an input into an output. So what's your input? What is the source of your water? Ask yourself, am I using surface water or groundwater? Is it wastewater that I'm using or reusing? Is it city water? Does it fluctuate? Does the quality fluctuate with time? Do I have an appropriate measurement program for water quality? And ask yourself also, what's in this water? Is it inorganic, organic? What's the concentration? Is it abrasive? Is it corrosive? And also ask yourself, what type of particles am I dealing with? Are they small? Are they large? You'll have a plethora of treatment processes in front of you, from intake screens to grit removal to aeration systems, activated sludge. Sometimes you'll have chemical coagulation, flocculation, but eventually you'll need to treat further, and you'll need filtration and membranes. Look at what you're producing. What's your outlet? Is it a product? Is it a consumable product? Or is it a discharge? Is it reused? Is it for heat transfer? And look at the flow rate you're treating, and discuss those issues, those questions with your partners. Let's talk a little bit about what's in your water, because that's very important too. Did you know that your eye can only see particles of about 50 microns? Well, that's pretty small, but you know, for a membrane, this is huge. So when you look at the fine stuff, studies and peer-reviewed studies show that particles that are really fine, below 5 microns, they tend to cling to surfaces. And in heat exchange applications, they tend to reduce the heat transfer efficiency. The small particles also can cause harm to membranes. An example of this is a city located in New York State, where a lot of industries, even institutions like hospitals, rely on city water to produce ultra-pure water. Well, the city has to issue alarm alerts because of aluminum carryover, and this aluminum plugs the RO. And those particles are really small, and the concentration is really low. And yet, sometimes those plants have to shut down because of that. So clear water is not necessarily clean. Particles can also damage your equipment, either by erosion, corrosion, or blockage. There's also bacteria to think about. Not only do they pose a health risk, such as Legionella, but also they can promote corrosion, like sulfate-reducing bacteria. So small micron particles are the biggest contributor to fouling, and sometimes they should be addressed first. Let's look at how fouling leads to losses in heat transfer. Heat transfer is important for many reasons. It is a huge energy consumer. In the USA, and a study showed that, that dates from a while back already, but the numbers are still impressive today. The cost of fouling was estimated at more than $14 billion in the US only. It was estimated in the Western world to be a cost approximately equal to 0.25% of the GDP of industrialized countries. So it is important to know that in closed loops, for example, inorganic scaling and corrosion, or biofilm, and even organic components such as grease, wax, carbon, or polymers can significantly reduce the thermal conductivity of the heat exchangers. And that translates to more maintenance, increased differential pressure, so more energy requirement just to pump water through the heat exchanger, increase in chemical costs, biocides, corrosion inhibitors, acid and caustic cleaners, and downtime. And downtime leads to production losses. The same can be said about processed water. Fouling leads to losses in membranes. Again, by scaling, biofouling, or silting. And what are those losses? Well, when fouling increases, the transmembrane pressure increases. So you need more energy to pump water through your membrane. So that's a first loss there in terms of energy. Your flow will decrease, and therefore you will produce less water. And that's another loss, a loss of productivity. Your cleaning requirement frequency will increase. You'll need to use more chemicals, and that, again, is a loss. You'll need more money to clean your membrane. More cleaning also leads to damage to the membrane in the long term, and more labor to replace those membranes. The membrane life will be reduced, the replacement frequency will augment, and the cost of disposal of that membrane is another loss. And finally, product quality might decrease because of your filtrate quality decrease. So again, fine particles lead to losses. So it's not only good to remove particles by weight, 90% or even 90% removal by weight can seem to be enough, but sometimes it is not enough. For example, in this schematic, if you remove 90% of the particles, the large particles will be removed first. You are left with the fine stuff, and that fine stuff matters. And so not only every drop matters, but every small particle in every drop matters. Remember that other technologies like conventional filtration or centrifugal separation have limitations in terms of removal of small particles. Hydrocyclones, for example, are limited to about 40 microns. Strainers and even multimedia filters are limited to 10 to 30 microns at best. Let's look in more details about, at filtration, because MICROSAND CROSSFLOW filtration is a media filtration application, and it is an improvement on traditional media filters. Traditional filters rely on several layers of media to filter particles. The first layer typically is coarse to remove larger particles. The second and third layers are finer to remove the fine stuff. But that leads to deep beds, more water usage, and more chemicals to deal with the replacement of that the water that is used during backwash. Reclassification of media is also required. So therefore, backwash cycles are not only using more water, but they're longer. And therefore, there is a loss of productivity when the filters are down. The best filter actually is something that nature invented, and it's the beach. Beach is a very fine sand, but of course, in order to filter an important quantity of water, you would require a very large surface area. So obviously, for practical purposes, and to avoid plugging of the media, we don't use a beach in our industry. We use media filters. The size of the media is coarser. The number of layers is increased also. It has a benefit. The filtration rates are pretty high. However, the efficiency to remove particles under 10 microns is not very good. So how do we compensate? Well, sometimes we compensate by adding chemistry, but that adds complexity to the system. We can also compensate for the lack of efficiency at small particle removal by adding one step of treatment. For example, in front of membranes, we will use cartridge filters. But that leads to increased operating costs because those cartridge filters plug up quickly and need to be replaced. So the inventor of CROSSFLOW microsand filtration, an engineer called Guilford Sharrow, in 1962 said, well, there must be a better way. I would like to be able to use a finer media to remove the fine particles. And he did try it, and he introduced microsand as a media. So microsand here will be defined as a sand that is about 100 to 150 micron in size. And the difference between the microsand used in this technology and the sand that is used in other media filters basically relies in its size and its shape. The density is very similar. So Guilford Sharrow used microsand in a conventional filter, but is it possible to use microsand in just any application, in any type of filter? Well, Guilford Sharrow realized that it wasn't as easy as it sounded. His first experience showed that microsand would not work efficiently with traditional technology. Particles are very quickly captured at the surface of the microsand, and they cause a phenomenon that we call blinding. And blinding of the surface leads to increased differential pressure through the media. And sooner or later, you have a risk of channeling. So water will break through the layer of dirt and then follow the path of least resistance. You'll have no filtration efficiency. The effluent quality will deteriorate, and so you're left with the same problem. So how do you maximize the benefits of microsand? Well, again, inspired by the beach, Guilford Sharrow introduced the vortex, hence the name BORDELEAU. And so he patented a combination of hydraulic flow and media size in the vorticend, and it worked really well, but his first systems were limited to about 300 gallons per minute. We'll look a little bit more at CROSSFLOW filtration, but before we look at it, we would like to ask our audience a second question. Freddie?
Thank you, Francis. Yeah, let's have a look at the question. So same process, time for the second poll that we're running in today's session. So audience members, please select the answer that is relevant to you and then click submit. So the question this time is, what is your primary water filtration goal? Possible answers are cooling/heating, process water, potable water, discharge, reuse, or other. So audience members, please select your answer now. And once again, Francis, perhaps you could just briefly comment on the question just to give our audience a bit more time to vote.
Thank you, Freddie. So this question is fairly straightforward. We want to know what your main applications are. So do you use water, and are your water treatment needs mainly in cooling and heating applications? Do you have cooling towers? Do you have chiller loops? Do you cool your process? Or do you have process water applications? Do you need water in your process? Do you need potable water? Are you producing potable water in your industry or in your application? Is your water going to discharge or is it reused? So by answering this question, we'll know a little bit more about the audience and their priorities.
Excellent. Thank you, Francis. Let's have a look at the results. So again, fairly interesting split there, quite even between those first three answers. Well, leading answer there, I should say, was 37.7% is processed water. What do you think, Francis?
Well, that's what I was expecting. Cooling and heating processed water definitely are two of the main applications in the industry. I'm really happy to see that discharge is only 5%. And reuse is 3 times more. It means there's something here. There's a trend to reuse water, and I like that. I think it's time to look a little bit more about cross-flow microfiltration, microsand filtration, and what benefits it can bring to your applications. So first off, it's important to say that cross-flow microsand filtration is media filtration, and it takes the shape of pressure vessels inside which we put a layer of media. Contrary to conventional filtration or multimedia filter, there's only one layer of media in cross-flow microsand filtration. It's a monomedia filter. And just like I was talking about a little bit earlier, it relies on 2 things. First off, a very specific type of media, and also a hydraulic pattern inside the filter, and we call it cross-flow, and it's represented here at the top left. Water flows top to bottom through the media, but it first goes through a patented injector that redirects the flow and generates a cross-flow pattern at the surface of the media. And this is what you see at the bottom right corner. This is a zoom in on the surface of the microsand. And so what you see is that flow does not travel vertically, it travels diagonally. A portion of the flow is sort of recirculated into the upstream area. And but at the end, 100% of the flow does go through the media. So what does that cross-flow generate? It maintains large particles in suspension. So instead of those particles being captured in a second layer of media on top of the microsand, those particles are kept in suspension. That sweeping effect at the surface prevents blinding and channeling. And the small particles are captured in the microsand. So this is essentially how cross-flow microsand filtration works. Where does the technology fit in the realm of technologies that are available to filter water? So this is a graph that some of you are already familiar with. Essentially, it's a scale of particle size at the bottom. The large particles being to the right-hand side and the very, very fine particles to the left-hand side. And corresponding to those particle size are different filtration technologies. So from very fine stuff, reverse osmosis on the far left, all the way to conventional filtration to the far right. So BORDELEAU cross-flow microsand filtration fits somewhere between conventional media filtration and microfiltration. So essentially, it fills the gap between multimedia filters and membranes. And BORDELEAU will capture particles between 50 and less than 1 micron, but a sweet spot really is where other filters have challenges, and it's in the sub 10 micron, sub 5 micron range. Let's look at a little bit more in details at the differences between conventional pressure media filters and BORDELEAU filtration. First, I want to focus on the media. Well, we said that media with microsand filtration is about 100 to 150 microns in size. Conventional filters use coarser sand, about 3 to 5 times larger, plus typically a layer of anthracite on top. The difference also lies in the bed depth. So we use a layer of about 8 inches or 200 millimeters of media, whereas conventional filtration relies on several layers, and the bed depth can reach 30 inches, sometimes more. This obviously leads to a gain in terms of equipment size and weight. It's easy to understand that with less media, the media is fairly heavy in the filter, there's a definite gain in terms of size and weight of the equipment. The third thing I want you to look at is the inlet TSS, inlet oil and grease. Like most filters, a filter is not a clarifier, so we are limited by inlet TSS. The CROSSFLOW filtration system prefers influence with less than 20 milligrams per liter. Although this will depend on the nature of particles, we can deal with higher loadings if the particles are mostly inorganic, and we can also deal with spikes of turbidity or spikes of suspended solids. The same thing can be said about most filters. Where we differentiate CROSSFLOW filtration from traditional filters is in the filtration rate. BORDELEAU typically filters at about 3 to 5 times the rate of conventional filters. That also leads to a significant gain in terms of surface area and size of equipment. We also rely on less water for backwash, so typically 6 gallons per minute per square foot for backwash, which is about 50% less flow. We also backwash about half the time of typical filters. Even though we do backwash more frequently, there is a significant gain in terms of water usage. So less water is used, and the filter remains available for filtration for a longer period of time. Where is BORDELEAU CROSSFLOW MICROSAND filtration used? It's used across many market segments. There's thousands of installations worldwide at the moment. Most of them in the cooling and heating markets or applications, but many of them also in process applications, food and beverage, for example, in water reuse applications, pre-RO, agricultural application and irrigation or rainwater reuse, even in oil and gas for produced water polishing. So it's a testimony to the robustness and the versatility of the process. Let's look at 3 case studies taken across very diverse markets and applications. We'll look at LAX and we'll look at how an upgraded filtration system for their cooling tower helped them save a lot of money on their operating costs. We'll look at COORS and how COORS, with their water reuse policy, has reduced its dependency on city water. And we'll look finally at pre-RO application in a paper mill in British Columbia. Los Angeles Airport in 2014 required side stream filters for their cooling tower. So CROSSFLOW MICROSAND filters were supplied as a side stream filter, filtering about 5% of the loop flow. Laser particle counts are used to measure and count the number of particles in different micron size ranges. Laser particle counts here showed that 95% of the particles were smaller than 5 microns, which is what we expect from a cooling tower application with airborne particles and scaling and very small iron particles. There were also very tight space limitations at LAX, and this is 2 reasons why BORDELEAU was selected. After the system was put in place, there was a return on investment analysis performed, and we have data that we can share with the audience. that demonstrated up to $300,000 of savings in energy, chemicals, and labor costs. A totally different application is with COORS. COORS has been a customer of Evoqua for many years, started in 2008. They have filters in 3 locations now. The most recent application is for cooling tower makeup. And they used to rely on city water for cooling tower makeup. And COORS implemented a very innovative and stringent policy for water usage reduction and wastewater reuse. So now we have BORDELEAU filters using diverse waste streams, treating them to act as cooling tower makeup. It's a challenging application, but BORDELEAU proved very successful in this application. Finally, a different type of application for the CROSSFLOW MICROSAND filter. Given that it performs very well at removing very fine particles, it was selected at Fraser Lake Paper Mills as pre-RO treatment in 2014, and shortly after we completed a very thorough R&D program where we developed the horizontal filter product line that you see in the picture. We supplied filters to treat well water, and well water contained high loading of iron and other calcium and other ions that are very detrimental to membrane, reverse osmosis membrane. Again, the laser particle count showed that all particles were smaller than 5 micron. After implementation of the BORDELEAU process, 99% of all particles were removed. And remarkably, there was a significant reduction of SDI, and SDI is a very important parameter for RO applications. 20 to 60% reduction of SDI was demonstrated. All of that without any chemical conditioning. So this completes our tour of the case studies. Let's wrap it up with our conclusions. So we looked at the right question to ask yourself when you select a technology. You have to know what you're treating and where you're putting this water. You have to care about what's in your water. You have to look at filtering small particles, especially because it yields numerous benefits. It potentially can cause numerous problems, but the benefits of filtering small particles obviously are reduced downtime, reduced maintenance, reduced chemical usage, reduced energy usage, and increased product quality. So all the benefits of filtering particles translate into cost savings. And traditional media filters typically fall short due to their inherent limitations in filtration capability. CROSSFLOW MICROSAND filtration technology is more than just a media filter. It fills the gap between multimedia filters and membranes. And so it's a new tool in the filtration technology portfolio, and it can help you accomplish your water filtration goals. So remember to ask the right questions, go to the right people, and remember the small stuff matters, and in every drop it matters.
Excellent. I'm afraid that's actually all we've got time for. Francis, is there anything you'd like to add before we conclude?
Well, I would like to thank you for organizing this webinar, Freddie, and I would like to thank everyone for joining us today. And we will remain available through the channels to answer more questions after this webinar is over. You can also go to our website, and I would like, if you don't mind, Freddie, to invite people to look at our website, www.bordesand.com, and also obviously look at other Evoqua products at evoqua.com. Thank you very much.
Excellent. So that just leaves me to thank Francis for what was a great presentation and to thank Evoqua for sponsoring the session. To the attendees, you'll receive an email shortly telling you how you can access the on-demand version of this webinar, or you can access this through our website, which is www.business-review-webinars.com. And once this webinar ends, today's survey will appear in its place, and we would appreciate it if you answer the questions in there. We also look forward to sharing further webinars with you, so please do keep an eye out on the website just mentioned, and follow us on Twitter at BRWebinars for daily updates, and join our LinkedIn group Business Review Webinars. Thank you once again, and I hope you all have a nice day.